Okay, we shall make a start then. So, good afternoon. Peter Thomas of Control Specialists. This is a webinar concerning PROFINET network design. It's one of a series of webinars that we're giving on behalf of the PAA, the PROFIBUS Association of Australia. Week before last week, I gave one on EMC awareness, which is applicable to all sorts of industrial networks, PROFINET, PROFIBUS and others, which you might want to look back on if you didn't attend. We're now going to start on a series of webinars associated with PROFINET. This one is on network design. Next week, we're going to do one on network diagnostics. And the one after that, we're going to do one on PROFINET gateways, where we're interested in linking PROFINET to other networks, maybe even PROFIBUS. And then after that, we're going to jump ship and start to look at PROFIBUS, and in particular, PROFIBUS lightning surge protectors and the difficulties that can pose when we're trying to qualify a PROFIBUS network. Okay, so on with this particular presentation then. Basically, we're an organisation that spend half of our time giving training on PROFIBUS, PROFINET and other networks, and also support. So I tend to teach the perfect world and then go out on site and see anything far from it. So that's the kind of background that we have. Here's the list of the webinars. We're on number 2 at the moment, the network design. If you're interested, just contact the PAA for information, and a link will be sent to you. Okay, so let's have a quick background then in terms of what PROFINET is. Bottom line is PROFINET is Ethernet, the same Ethernet that you have in your office, works on 100 megabits per second. And although it's a predominantly copper-based network, we can use fiber and we can use wireless. Most recent numbers from PI, and PI are the vendor independent organisation that are responsible for the technology, the marketing, the training of PROFINET. They reckon that on the last count, there's approximately just over 30 million PROFINET devices out there. If we was to look at a similar graph for PROFIBUS is way above this, up in the 60 million. However, it's starting to slow down. And certainly from a UK perspective, what we're tending to see is that the migration to PROFINET is very much on an industry basis rather than a company basis. So if we go to logistics, airports, etc., factory automation, they're generally moving over to PROFINET, and some of them have been there for some time. They consider PROFIBUS a legacy network, and yet you have other industries like the water industry, the chemical industry, etc. Very much PROFIBUS is state of the art, and that's where we are. So PROFIBUS is going to be around for a long time yet, but there is a move over to PROFINET, if not only because the manufacturers of devices are trying to push people that way, but there is a number of advantages of going down here. Okay, so just go back to that particular slide there. That yes, this is just you may have seen this on other PI presentations. What this is trying to instill in you is that when we look at a cable going between a PLC and a device, if we wish to do this in the PROFIBUS world and use an analyzer to look at what was inside the cable, we would only see PROFIBUS traffic, nothing else. If we do the same with PROFINET, you're going to see PROFINET traffic and standard Ethernet traffic that we're going to call non-real-time traffic. Even if you plug a laptop in, excuse me, even if you plug a laptop in, you will see Ethernet traffic. And that's the kind of the world that we are now moving towards. And effectively, there is absolutely nothing wrong with you having a PROFINET network and non-real-time or standard Ethernet devices. In theory, if you wanted to put a printer on there, a camera on there, it would work fine as long as the network is designed. And from my point of view, in terms of having support calls, I've yet to have a support call where I'm called out on a physical thing. In other words, connection, cabling, the kind of thing that you get called out on PROFIBUS. However, I've had several calls where there has either been a no design at all or an uncontrolled change to that design, where the network starts to become dominated by these non-real traffic. And that is basically the biggest issue. So let's put some words down in terms of the main components. We have I/O controllers. We don't have masters in the PROFINET world. If you think about Profibus, a master and a slave has connotations of one being superior than the other, and that presumably is really correct, because the master is the only guy that in a Profibus world that can actually initiate communications. In the PROFINET world, that's not the case. The I/O controllers, PLCs to you and me, and the I/O devices, slaves in the Profibus world, they have equal rights. They can both initiate communications. These I/O devices, like Profibus, they can be remote I/O, drives, pumps, valves, etc., etc. We have switches to join them together. We don't necessarily need a switch, but generally there will be one or more switches in a PROFINET network, and the choice of switches is particularly important when we get down to doing the qualification and the support of a PROFINET network. And then finally, we also have gateways. Very rarely do PROFINET networks sit in isolation. There's always a need to connect to something else, be it another PROFINET network, a legacy Profibus network, because we don't want to remove all of the investment that we've put into Profibus. We might want to connect to RZ, CAN. We might even have a need to connect to some higher level Ethernet network for analysis using protocols such as OPC-UA and MQTT. Gateways we'll be talking about in more detail in a few weeks' time. But then we come on to the monitoring tools that, as I'm going to show you, essential for the qualification and support of the network. Many times I see sites that in reality have only been qualified as part of the normal application testing, where they assume that in the absence of the PLC kicking and screaming and there being no bus fault light, then the network must be fine. And that is wrong. The PLC is more than capable of working on a network that is close to the edge and not tell you about it. It will basically, PLCs from a PROFINET standpoint of view can really be relied on to tell you the blatant obvious, and that's you've lost communications. And very often the guy that you've lost communications with is not the guy that's causing you the problem. Okay, so this is a schematic of the network that we use as part of our training and development. It's quite a busy network. It's got approximately about 35 devices, but we've tried to put in here all of the different kind of technologies that we're likely to see. Not going to go into this in too much detail, but I'll give you the general idea. What we have at the top left here are two I/O controllers, two PLCs. Why two? Well, the reality is I basically screwed up when I ordered the first one, in that I underestimated the capability of the PLC. So there's a learning exercise. But two, in the fact that many PROFINET networks have more than one controller on the network. I'm going to ignore these bits in the middle for a minute. So we've got two controllers. We've got a switch, in this case a scalant switch, that's going to allow us to connect to the outside world, to the rest of the network. We've got some other switches here just to add complexity, a couple of them in series, and over here we have some floor standing cubicles, and in each of these are some I/O devices. We now need to join these together. First of all, our controller needs to connect to the switch. Ignore these guys here, the ether mirror and the tap. I'll explain them shortly. Just assume that they're not there. We connect to the switch, and then we go out. We first of all connect some laptop, local PCs to these individual racks for diagnostic purposes, and then we start to connect the network together. And you can see that basically what we have is rack 1, 2, and 3 are basically controlled by I/O controller 1 at the top left, and racks 4, 5, and 6 are controlled by I/O controller 2. The little red circles are something to do with what's called port mirroring, which I'll explain later on. That's the basic network. We've got the ability to do remote access, which we'll be talking about again in the future. And then we've got a number of gateways. It's highly unlikely that your network will have all of these gateways in, but they're there just to show you the kind of basic idea of what we can have, and we'll basically connect these into our network as well at this point. And then having done all of that, we've then got some remote access. So yours may be more complex, less complex than this, but that is a typical PROFINET network. Just to briefly explain, these guys down here, these are the qualifying tools, the support tools that we're going to use, and I'll explain why we've got these in. So this is the basis. So how do we go about designing such a network? Very often the PROFINET is treated as a kind of a plug and play environment. If any of you have actually configured PROFINET, it's really easy, especially if you've done it on PROFIBUS, and you can be led into a false sense of security that just add a new one, no problem at all. And that generally is the case, but things can come back to bite you in the future. So basically then, the ease in which PROFINET networks can be configured can lead us to this false sense of security in terms of robustness, support, and future expansion. We might have got a top-end PLC giving us diagnostics until we're blue in the face, but when the push comes to shove and we've got a fault, you'll very often find the PLC is probably not telling you very much use. Poorly designed networks present the risk of underlying network related issues that may only become apparent after several months or maybe even years. So if you have this imaginary cliff edge, you don't know how close you are to the cliff edge. You could literally be peering over it and the bus fault light on the PLC would not be on, and you would be fooled to be thinking everything's fine. It's only when you make a slight change, something that you've done many times, and all of a sudden you've tipped yourselves over, and then the PLC will then tell you. So main thing to remember, first of all, a PLC absence of bus fault does not necessarily indicate a healthy network. And what we're going to do in this presentation is basically bring you an awareness of the things that you need to consider to make sure that you've got a reliable network now and for future expansion. So what are the considerations that we need to give? Well, first of all, the choice of components. We'll have a brief look at that. The device naming conventions and the cycle times of these devices. Any connectivity to other networks, any requirements for IIoT, Industrial Internet of Things. Network security, clearly a big thing. PROFINET is an Ethernet based system, so just as prone to attacks as ordinary Ethernet in that respect. How we're going to connect these together, and do we need any redundancy? Equipotential bonding, a brief discussion about that. I went into that in a lot of detail in the EMC awareness in terms of making sure that our network is installed correctly to basically mitigate against the possibility of EMC issues. Application profiles, which you may not have heard about, and it's useful to be aware of that, especially from an end user. This can save you quite a bit of money moving forward. The training and support that you might want to consider, and then finally the qualification. How do we know that our network is actually working properly? Okay, so that's what we need to cover. That's what we're going to go through over the next half an hour. So IO controllers. Well, contrary to popular belief, PROFINET, like its predecessor PROFIBUS, is not a Siemens network. Basically, Siemens heavily influence and heavily fund PI, but there are many other big manufacturers out there all looking for your business and basically able to do a complete network themselves. But there is nothing wrong at all by having a Siemens PLC and no Siemens devices anywhere else on the network, or a Phoenix PLC and Siemens devices on the network. You can mix and match as you see fit, no problem at all. But we're going to call PLCs now IO controllers. They're responsible for the overall communication of a PROFINET network in the same way that a master was on PROFIBUS. Whilst most networks are only going to have one controller, in other words, one PLC and many devices to talk to, it's quite permissible to have many controllers, each controlling their own devices. That's not an issue at all. The total number of devices including any future expansion, needs to be determined beforehand, because you can have an expensive mistake, as I did in my case. On our network, we're using an S7 1200, so clearly at the bottom end of the PLC. I needed to configure just 35 devices, and when I added my 16th on the 1200, I got a pop-up message to say you've reached the limit. Now, I wasn't aware of that, but that was my fault. I didn't read the spec sheet. Better you do this on a real project and make sure you avoid any embarrassing conversations and expenses. So just be aware, all I/O controllers are not the same. PROFINET can coexist with conventional Ethernet devices. It's designed to do that. But remember that when you're looking at the hardware configuration of the I/O controller, it is only going to show you the devices that the controller is talking to. In other words, if you were looking on a new plant and you thought, well, the hardware configuration will be a good starting point, he is not telling you the full story of everybody that's on the network. This also means that the controller is not aware of other devices that may become added to the network, servers, etc. So he's got no way of knowing what the network load is going to be. If your network is going to consist of conventional Ethernet devices that will send and receive large payloads, maybe cameras, that kind of thing, you're probably best to save yourselves a lot of time and effort and buy a dedicated communications processor on that PLC. Let it do the work. That said, that's not necessary. If you're prepared to do the work in terms of design, and there are tools available, and you've got that information, then PROFINET and Ethernet can definitely coexist. I'm just giving you a bit of practical advice there that you might want to consider, and then it's not a problem you've got to worry about in the future. Excuse me. Okay, so I/O devices, the slaves in the Profibus world. Basically, all the big manufacturers are out there looking for our business. Most of them are designed to be mounted inside a panel or a cubicle. They will typically have an RJ45 port. In fact, nowadays you tend to have them with 2 RJ45 ports. And one important thing to be aware of is that every 2-port I/O device is actually a 2-port switch. And that's going to have connotations for us when we start to look at how we're going to connect these and the availability that we have in that network. Some devices have M12 connectors because they need some IP rating, maybe that it's going to be in a dust or a moisture-laden environment. Each I/O device has to be given a name, and when we start from a brand new system, then it is the responsibility of the person configuring the system to literally configure every device with a unique name, and that name has to match the name that he will ultimately type in the hardware configuration. And the reason for that is that every I/O controller, when you first start it up, always looks for a device by device name. He does not look for the device by IP address. The support and diagnostic capabilities of the devices can differ. Some of them have got web interfaces, some of them just use LEDs to indicate a basic error. So they've all got their pluses and minuses, if you like. Every I/O device must have a device-specific GSDML file, like Profibus, very, very similar, called GSDML because it's written in XML, but literally the GSDML file has to be imported into the library of the I/O controller. Without that, that controller cannot communicate with that device. And the information within that GSDML file will also allow the controller to determine that, having found the guy by name, he needs to confirm that the guy is actually the right guy. In other words, that I'm talking to a drive rather than a remote I/O. So all this is kind of handled in a similar way to how Profibus works. Now, switches. It is quite permissible, quite possible to have a PROFINET network connected very similar to a Profibus network. In other words, a daisy chain, in and out, a long line of them. Clearly, there's going to be cost advantages to doing that. There's no switch involved, apart from the fact that, if you remember, each device is a switch itself. But there are some rules about that. We can't add device after device after device in a long line and expect a very fast polling rate. So there's some rules that we'll talk about. But certainly from a support point of view, this line topology does give us some limitations in terms of fault finding, especially when we're trying to determine which particular device has got the problem. So in terms of the switch itself, then first of all, an unmanaged switch will be fine as long as it supports something called the quality of service. And the quality of service is what gives the switch the ability to prioritize a PROFINET telegram compared to anything else. But that only goes so far. If the Ethernet traffic has already been allowed through, well, the quality of service is of no use to us. So certainly unmanaged switches, no interface, they're fine. But going down that road is bad news when it comes to the qualification and support of the network. And basically, you are strongly advised to basically install managed switches. And in the PROFINET world, we have a conformance class B. And conformance class B is basically a managed switch for use in an industrial environment, but that's got a few bells and whistles to facilitate qualification and support. And basically, amongst other things, they support these things like port mirroring, which I'll explain later on, SNMP, Simple Network Management Protocol, and LLDP, Link Layer Discovery Protocol, all used for diagnostics and topology, etc. These conformance class B switches, rather than just conventional managed switches, also have a GSDML file, which means that the switch itself now forms part of the IO configuration or the hardware configuration, and the project all is being kept in one place. If we have a network with one or more switches that are just unmanaged rather than managed, that's going to not only have implications in terms of the network-wide diagnostic capabilities, but also is going to severely limit any PROFINET diagnostic tool that you subsequently go out and buy. They will assume that these devices can support protocols like SNMP and LLDP, and I've lost count of the times where I've been on site and they've spent quite a bit of money on diagnostic tools because they all look nice and shiny and nice and wonderful, only for them to basically tell them very little more than they knew anyway, simply because the infrastructure doesn't support that, and by that time it's probably too late and too expensive. Now, what about the device name? If you're a Profibus person, you know that you have to go to each device, give it a node number. But then when we're trying to support this, if somebody says node 70 has gone off the line, what's node 70 mean? So basically, in the PROFINET world, we identify devices by names. And these names have to match what the PLC guy is going to type for its instance in the hardware configuration. So it might be him doing both ends anyway. On power up, the IO controller looks at his hardware configuration and does a search on the network for a device by name. At this time, the device will not have an IP address. If he finds a device by name, then the controller will allocate that IP address to that particular device. Remember, at this point though, even though he's allocating an IP address, he still doesn't yet know whether the guy is the right type of device. If there's been a mistake, he's very simplistic. He's looking for him by name. They need to be unique on the network. They have to conform to criteria, so things like you can't use uppercase, there's certain characters you can't use, etc., etc. But it's relatively straightforward. But you should really try to take advantage of this facility. A lot of people tend to use the IO controller's ability to, or more correctly, the programming software to give a name, but it tends to be a techie name that is of no relevance whatsoever to the application. We should be looking things like, for example, pump 123.7 and things like that, something that relates to our particular application. Many tools available to download. It does not necessarily require the use of the programming tool like TIA Portal, Step 7. They are free to download tools. Here's one from Siemens called ProNetter. Once we've got the network up and running, we also have to think about the situation of what happens if the device fails, if it dies on us. In the Profibus world, you'd go to the stores, you'd plug a new device in, you'd set the address as per the other device, and up it would work. In the PROFINET world, that's not the case. He needs a name. Now, this is going to be once in a blue moon event, as we would say, meaning that by the time this happens, all the system integrators may well have long gone, and there's a guy there, a technician, trying to think what's going on. He needs some software. He might never have used the software. Even if he's got the software, he might not know what the device name is. So we can have a feature enabled at design time where the controller will, or the network will build up information to automatically rename that device once it's been working. And that is enabled by you configuring the topology feature within the PLC environment. Very easy to do, but if you don't do it, it means that every replacement device that you put on the network, or the technician is going to have to give it a name before the PLC will talk to him, because he's looking for him by name. Now, cycle times on the Profibus, in the Profibus world, our concern was, what did we want the network speed to be? And we had 9,600 kilobits per second up to 12 megabits per second. Very techy. Cycle times really should be a function of the process that we're talking, not in terms of the bit rate. So, for example, if you work in the water industry, then what is the point of asking a level controller for the level of a reservoir every 10 milliseconds? Because you're going to get the same answer every 10 milliseconds. Whereas if we're looking in robotics or high-speed conveyors, it's very critical that we poll it very quickly. And in the Profibus world, we had to have a network-wide bit rate. If there were one or more fast devices, then the network as a whole had to be fast. With Profinet, it's different. First of all, we don't have a bit rate to adjust. It's always 100 megabits per second. It's fast Ethernet. What you do have, though, within the I/O configuration is the ability on a device-by-device basis to set the polling rate of each particular device in units of time. There's two variants of Profinet. One's called Profinet RT and one's called Profinet IRT. RT is real time. Let's say 90% of the Profinet network, maybe 100% that you're going to see are Profinet real-time devices. But if we've got very fast communication requirements for high-speed robotics, then we need something called isochronous real-time, which will require special switches and special hardware. So you need to be aware of that. But basically, the main difference is what the fastest polling rate can be. And typically, RT can go as low as a millisecond. Now, that is quite fast, certainly in most of the industries I work in. But even that isn't fast enough for some, and IRT will go down as low as 32 microseconds. So just be aware of that. Most of what I'm going to talk about now is really RT, because that generally is most of the Profinet applications. So what do we set this to? Well, if we want to, we can let the PLC do it. But if you remember, the PLC doesn't know everything about the network, especially if we have lots of other Ethernet devices on our network. So it would be far better if we could make an informed decision. And fundamentally, the choice of the polling rate really is a process decision, because we need to have an idea of the closed loop response of this. Is this a slow system? Is this a fast system? So the bottom line is, on a device by device basis, the polling rate should be set as high as necessary, not as high as possible. And if you move away from that, then we can have problems moving forward in future expansion. And it's one of the adjustable parameters available for us for adjusting something called network loading. We're going to talk about the criteria for the qualification of a network. And one of the things is that we would like to be generally running at less than or equal to 20% of network loading to allow for bursts and future expansion, etc. Be aware, though, that some devices have a minimum cycle time. So whilst they might be RT devices, that's not a guarantee that they will be 1 millisecond. You will need to look in the spec sheet or the GSDML file to tell you what the fastest polling rate is of that device. Also be aware that by default, the watchdog agreement between the controller and each device is 3 times that of its polling rate. So if we've got a device set at 2 milliseconds, then as long as the controller receives data with at least one telegram within 3 times that, so 3 times 2, 6 milliseconds, he will be fine. Now, we should be really hitting it every 2 milliseconds, bang, bang, bang. But if we miss one, it's not going to cause the PLC a problem as long as he gets one within 3 polling rates. But he won't tell you that he's missed one because he's operating within design criteria. But we would like to know that. The PLC is not likely to tell you unless he terminates the communication, which he will do so if we haven't had the polling rate with at least one telegram within those 3 polling rates. What about connectivity to other networks then? Very few industrial networks now exist in complete isolation. We might have other PROFINET networks to connect to. We might want to connect to, so apologies for those of you that are busy putting Profibus networks in at the moment, but some industries do treat Profibus as legacy networks. But we might want to continue using them, but connect our PROFINET net together. Maybe we've got DP, maybe we've got PA. We might have other networks that are nothing to do with Profibus and PROFINET, CAN bus, IO-Link, RZ, and so on. And then we got couplers from many, many manufacturers that will facilitate this. And basically all of these guys, so we've got Helmholtz, Softing, Siemens, IFM, and others. These devices all have one common thing in between themselves, and that is that on one side they appear as an IO device, which basically means that these devices on the PROFINET side will have a GSDML file. The guy on the left, the PROFINET to Profibus gateway, he will come with a GSDML file for use with the PROFINET network and a GSD file for use in the Profibus network. So he appears in 2 hardware configurations. Neither network knows about each other. They're just talking to this guy as though he's just another device on the network. That's another consideration that you need to get to. We're going to look at that in more detail in a few weeks' time. Maybe there are now IIoT, Industrial Internet of Things. There's more and more requests now whereby manufacturers are either seeing or being led to believe that there is data in their system over and above the normal IO data that could put them in a competitive advantage in terms of analyzing the response of their process. And that tends to be done in a higher level system, but basically this data resides in our factory level environment. In other words, it's there on potentially there on our PROFINET network. So what we can do is, although this would not be PROFINET traffic, we can use Ethernet traffic to get additional data out of these devices, out of the instruments, and then send them up onto an IT network. And at the moment, although PI are generally supporting OPC-UA, the reality is MQTT, which is message queuing telemetry transport, very, very popular in the home automation. This seems to be now starting to appear in industrial installations, and if more so because if you now get the latest firmware on Siemens PLCs, they support both OPC-UA and MQTT. They're both doing a similar thing, but they are very, very different. I'll show you, if you're interested in this, I'll give you a quick demonstration of the use of MQTT when I do the gateways in a couple of weeks' time. Yes, you can buy PLCs that support this directly. If you haven't got that with your particular PLC, you can buy dedicated bits of kit that facilitate this. So at this moment, you need to give consideration. Is this something that we or our client need us to think about? Security, an obvious issue here. As soon as we get somebody plugging a laptop in on our PROFINET network, anything on that device is potentially capable of getting onto your network. So we should be looking at security or designing our network with security in mind from day one. PI have guidelines which are available from their website, and the eventual solution would clearly have to be done on a risk-based analysis, but generally I think it's fair to say that whatever you're going to do, it's going to include one or more firewalls in here, industrial grade firewalls. I've chosen this one here, Helmholtz, simply because that happens to be the one that we have on our demonstration rigs, and I'll be talking about this in a few weeks' time as well. And what this little guy has the ability of doing is, although it looks like a switch, that top port is connected to the WAN, which is the IT network, and the bottom three, they're just connected to our PROFINET network. This is not a PROFINET device, it's an Ethernet based device, and we can use things like packet filtering and something called network address translation, such that we could have our support people initially sat on the IT network, accessing resources like web servers, etc., on the PROFINET network. In other words, reducing the amount of time that people have to spend literally plugged into our PROFINET network. Very easy to set up. Siemens, Phoenix, they all have these kind of things. I wanted to show you this guy simply because it was very easy to set up and it didn't blind you with science. Topology. If you think about the Profibus world, unless we're going to use hubs, then we're pretty limited with what we can do in the Profibus world. We have to have a daisy chain in and out all the way. When we're using PROFINET, we've got a number of options, and we can have line, tree, line, star, tree, and ring topologies, and each one has got its own advantages and disadvantages. If you think of low cost, well, then maybe a line structure is the one for you, but that's going to impose issues because we can't add device after device after device in a long line there, as I'm going to come to in a minute. A star has got a switch in the middle, a common point of failure, but also a device that could now tell us on a device by device basis which particular device is causing us a problem, especially if that device is a conformance class B switch. We have tree, this idea of islands of automation and switches, and we also have a ring. Be aware though that although PROFINET supports a ring, the devices in that ring have to be able to support a ring-based protocol called MRP, which is Media Redundancy Protocol, and it's not a given that they do. So if you want a ring, fine, but just be aware of that. There are some other limitations as well with a ring, and if that's something that you're looking into, I'll be giving you my email address at the end, and you can drop me an email and I'll get back to you on it. Wireless, we shouldn't forget the fact that wireless and Bluetooth are now coming into their own, especially where we've got difficult to handle situations of moving devices, maybe gorges, water, etc. And these are now used with success. And in fact, some, and maybe all of these, I can only quote comment about one in particular, that's the guy at the bottom from Schildknecht in Germany. They've even got TÜV approval for use in safety applications, and I'm fairly sure all of the other guys are doing the same as well. So it's got to that level of robustness and reliability, and it's something they're very easy to set up. They do not appear as a device, they're completely transparent from the PLC point of view, or the IO controller. And basically the way in which these tend to be done is where, for example, we've got our controller. I've kept it simple here. We've got a couple of devices connected via PROFINET, via copper cable, and then there is some difficulty getting to the devices at the far end. So we've just brought these two together. Very easy to set up. It's just a matter of selecting a channel, and we can have up to 300 meters line of sight, which everybody seems to question, and I keep going back to the manufacturer and they say, yeah, definitely you can have that. Very often now that this is Bluetooth technology rather than wireless. Be aware though that this will limit the cycle times available. If you're looking down at 1 millisecond, you're going to struggle doing wireless. But if you was 30 milliseconds, which is fast for many applications, you'll be absolutely fine. And there's various ways of doing this, but certainly very reliable. I've seen them in use many, many times. So what have we actually got to do from a design point of view? Most people are concerned about the design of their application program, which is writing software, but I'm talking about the network design, which very few people do. Well, basically, there are tools available, and to be honest, I'm only aware of two of them. One's from Siemens, and one is from a German company called Ingersoll. They both allow you to drag in devices in a virtual environment to basically do what-if scenarios, and in doing so, it will identify bottlenecks. So you can basically put your PROFINET network there and then add non-real-time devices. Having said that, out of the two, clearly the Siemens is very Siemens specific. If you are a Siemens user, it's a really good tool. However, it's very complex, especially when it comes down to you putting the numbers in there. You've got to load a lot of information. It is quite easy to use, having said that, but I often wonder whether smaller system integrators will have the resource or the information to use this. But there's a good webinar on the Siemens site to have a look at it, and this is called CNET Plan. It's even got the ability of doing online monitoring and then building a topology from that. This is after the event to try and show you bottlenecks. But the whole idea of this is to design the network, and then we create that in our IO controller. Redundancy, we've talked about media redundancy of the cabling, but we've also got now the capability of maybe redundancy at the controller level, redundancy at the device level, or both. So these are all supported and capable, but you've got to check that your devices will support it. It's not a given. PROFINET will, but not necessarily your particular controller. One of the fundamental things about all of this with PROFINET is it's green cable, and it's critical in the fact that we've got to get the data from A to B. And we're only going to get that from A to B if we're using decent quality cable installed in the environment it's intended to be used. So if I want to connect my PROFINET network up in an office environment with cheap cable from the local electronics store, it will work, no doubt about it. Whether that would be the case in an industrial environment is a different matter, and I would suspect is the answer to that is no, it wouldn't. And one of the things that you have to do is make sure that we're using screened twisted pair with the shield connected at both ends, which is very contentious. If you want to know why that is and the techniques behind it, and why you need to look at the webinar that I gave last week on this. This is not a PROFINET requirement. This has been going back for the last 20 years, and people still have difficulty in deciding, what do I do it at one end or both ends? Have a look at the webinar, and if you're still confused, then give me a shout. But bottom line is, when we talk about it connecting it ground or earth at both ends, the problem that we have is that very often we're connecting it to the local safety earth, which will be fine from a safety point of view, but a conventional safety related earth bonding system is not necessarily good enough for EMC. And although I realize this is a European standard, there tends to be an international aspect about it. And there is an international standard that I mentioned, recommends moving towards a mesh bonded network. This does not mean a site-wide review of your bonding, far from it. Just watch the webinar, but be aware that we do need the shield connected at both ends. And the technical term is your bonding system needs to provide a low impedance typically less than an ohm, at the frequencies of concern. And the frequencies of concern are what kind of emissions can I have from the equipment on our system. And if you are people that use drives, then it would be reasonable to assume that you could have emissions from drives, especially downstream of the drive, in other words, between the inverter and the motor, of up to 10 megahertz. That's probably the high end, but certainly it's a nice round number. There are tools available for you to have a look at that and to improve on these. The guy on the right, a simplistic approach to it, but quite useful, at least to prove the fact that the shield has been connected without you having to disconnect the connectors to confirm it. Profiles, I'm now realizing that I'm getting to the 45 minutes. I'm in no rush, but I suspect some of you are. So we just got a few more things to go through. Profiles are very important. This is nothing to do with communication, but basically it will improve the usability and the flexibility of your system moving forward. Basically, there are many of them supported by PROFINET, but the most common ones are PROFIDrive, PROFISafe, and PROFIEnergy. I'll briefly explain what PROFIDrive is. Imagine that you are an ABB drive user, chosen ABB as a reputable manufacturer of drives. And the PLC guy has configured it, it's worked for many years, and several years later it fails. And for some reason, the end user has decided to change to a Siemens drive or some other drive. Yes, he's got to give it a name, but it may well be that he's got to get a PLC guy in because the I/O mapping is different. If you buy a drive that supports PROFIDrive, and many manufacturers, including ABB, including Siemens and others, support this, and it's basically an agreement that the formatting and ordering of the data will be the same. So it saves you a lot of time and effort. PROFISafe for functional safety, light barriers, emergency stop. PROFIEnergy, energy conservation, the ability to turn off certain parts of a network when, for example, we've gone away on lunch or some kind of break. So very briefly, not all devices support everyone. Have a look at them, make sure your device supports it if you're interested in it. And then we go on to, we've got all of this, we spent all of this time designing our network, buying the equipment. What about the diagnostic tools? Well, first of all, although the PLCs themselves are very, very capable, even the high-end ones that I've seen are more associated with I/O device issues, be able to tell you what a problem is within a given device. But when it comes to the communication, it's very high level. I've lost communications. It's as basic as that in many of them. So we can't really rely upon the PLCs or the I/O controllers to provide this low-level indication of network functionality. And you can buy a number of devices. There's three main companies around. There's Procentec from the Netherlands, there's Indersol from Germany, and there's Softing from Germany. There are others, but they're the big guys, really. Whoever you go to, they will take two forms. You can buy active analyzers, and the clue is in the name. These devices actively poll the information. They are sending additional traffic on the network looking for diagnostic information. And we have passive analyzers, and these literally have to be in series in the network, and they are monitoring the traffic between the controller and the first switch. And some are active, some are passive, and some you can buy extra bits to make them active and passive. The bottom line is you need both to fully qualify the network. But remember that if you buy an active analyzer, no matter who you've bought it from, if you've got a network full of unmanaged switches, you will severely constrain the diagnostic capabilities of that device. You won't prevent them completely, but you will constrain them, and you may be disappointed in terms of what you've got for your money. I'll be going into these in a lot more detail next week. We also then want some kind of qualification, and this is really some kind of documentation that you've put together to basically define the quality criteria of your network, and the diagnostic tools I've shown you are basically very useful to provide evidence for that. We'll talk about the quality criteria next week, but again, remember, a PLC with no bus fault, no indication or guarantee that there aren't underlying issues. So we are doing training at the moment in the current situation. We normally do face-to-face. I've delivered training in Australia around several cities many times. That may be happening again, not sure when. Clearly not possible even in the UK. So we're doing online training, and we're doing half-day and one-day training. We could, in theory, do that for you guys in Australia. With we'd have to just look at the time. But depending on numbers, we can actually give you access to our network remotely. And what we've been done so far, the feedback we've had from that has been very positive. And that whilst nobody said they prefer it, compared to face-to-face, they found it surprisingly usable. Okay, so I'm going to just have a look now at the chat window, and basically now say if you want to ask any questions via chat, and as I've said, this is going to be recorded. You will get the opportunity. If you have got any questions, well, then my contact details are there, either via email or via LinkedIn. I hope you found this of some interest, and that most of the point it's allowed you to move forward in the world of PROFINET. If you're interested in taking it a little bit further, then as I've mentioned, there are a few webinars moving forward. Okay, so unless there are any questions, we've come to the end. Thank you for your time, and I will hopefully speak to you again in the future. Thank you very much. Goodbye.